Dear students, today I am going to explain rules for the calculation of oxidation number. What is oxidation number? The number of electrons which the element loss or gain is called oxidation number. When the element loss electrons, it has positive oxidation state or oxidation number, and when the element gain electrons, it has negative oxidation state. For example, sodium atomic number is 11. So it has the tendency to lose one electron to get noble gas like neon 10 structure. So it has +1 oxidation state. Example 2. Chlorine atomic number is 17. So it has the tendency to gain one electron to get stability like argon 18. Argon is a noble gas. So chlorine has -1 oxidation state. Rules for the calculation of oxidation numbers. In elements, in the free or the uncombined state, each atom oxidation number is 0. For example, hydrogen H2 molecule, Cl2 molecule, O3, ozone, phosphorus, sulfur molecule. These molecules has homogeneous, that means similar atoms combines to form these molecules. So the oxidation state of these molecules is 0. And sodium, aluminum, magnesium, these are the neutral atoms. The oxidation number of neutral atoms is also 0. Second point, for the ions composed only one atom, the oxidation number is equal to the charge on the ion. So we call monoatomic ions. So for monoatomic ions, the oxidation number is equal to its charge. In case of polyatomic ions, the sum of the oxidation numbers is equal to its charge. For example, Na plus is a monoatomic ion. Na plus ion has oxidation number +1. That means that is equal to its charge, and O2 minus oxide ion has -2 oxidation number. So example, next example, SO4 2 minus, this is polyatomic ion. For this polyatomic ion, if the sum of the oxidation numbers of sulfur and oxygen is equal to -2. Number 3, the oxidation number of oxygen in its compound is generally -2. There is some exemptions for oxygen. In case of peroxides, oxidation state of oxygen is -1. H2O2 hydrogen peroxide, sodium peroxide is example for peroxides. In case of superoxides, oxidation state of superoxide, oxygen oxidation state is -1/2. K2O is the example for superoxide. In oxygen difluoride, oxygen oxidation state is +2, and in dioxygen difluoride, oxygen oxidation state is +1. Next, fourth point, the oxidation number of hydrogen in its compounds generally is +1. But in metal hydrides, lithium hydride, sodium hydride, calcium hydride, these are some of the examples of metal hydrides. In metal hydrides, oxidation state of hydrogen is -1. That is a special exemption for hydrogen. Next, fifth point, the oxidation number of fluorine is -1. This is very important. At any case, oxidation number of fluorine is -1 because fluorine has highest electronegativity. Chlorine, bromine and iodine, when combined with oxygen, oxidation state is +1. So these are also no halogens, but except fluorine, the remaining are also shows +1 oxidation state. Sixth point, the algebraic sum of oxidation numbers of all the atoms in a compound must be 0. in a compound. So, seventh point, in polyatomic ion, we have already discussed this, the polyatomic ion, the algebraic sum of all oxidation numbers of atoms of the ion must be equal to its charge on the ion. Eighth point, the oxidation state of first A, second A and third A, fourth A groups elements is equal to its group number, and the oxidation state of fifth A, sixth A and seventh A and zero group elements is equal to group number minus 8. Suppose if any element belongs to fifth A group, the oxidation number is equal to 5 minus 8, that means minus 3 is the oxidation state. Next, so with the use of these points, you can calculate the oxidation state of any atom in a compound. Suppose here NaH2PO4, underlined atom is phosphorus. Here I will explain how to calculate the oxidation number of phosphorus. Here the sodium oxidation state is +1 because sodium belongs to first A group, so the oxidation number is equal to group number, so sodium oxidation state is +1, and one hydrogen oxidation state is +1, so here two hydrogen atoms are there, so the total oxidation number for hydrogen is +2. And let us take the oxidation number of phosphorus is +x, and the one oxygen oxidation state is -2. Here 4 oxygens are present, so 4 into -2 -8 equal to, this is a compound, there is no charge on it, so equal to 0. X minus 5 plus 3 minus 8 is -5, so x minus 5 is equal to 0, x is equal to +5. So phosphorus oxidation state is +5 in this compound. And next one, NaHSO4, here the underlined atom is sulfur, so we need to find oxidation state for sulfur. Sodium +1, hydrogen +1, sulfur, let us take sulfur is x, and oxygen 4 into -8, 4 into -2 -8 equal to 0. So x minus 6 equal to 0, x is equal to +6, so sulfur oxidation state is +6 in this compound. H4P2O7, here 4 hydrogens +4, 2 phosphorus 2x minus 14 equal to 0. So if you find the oxidation state of phosphorus, x equal to +5. And potassium permanganate, here we want to find the oxidation number of manganese, Mn. So 1 plus 1, potassium belongs to first A group, so oxidation number is +1, and manganese x, and 4 oxygens -8 equal to 0, x equal to +7. And oleum, pyrosulfuric acid, here 2 hydrogens +2, 2 sulfurs +2x, and 7 oxygens -14 equal to 0, 2x minus 12 equal to 0, 2x equal to 12 and x is equal to +6. Most important thing of this example, H2S2O8 part disulfuric acid. Here peroxide bond, we call peroxy bond. There is a bond between two oxygen atoms, we call peroxide, peroxy bond. The oxygens belongs to peroxide bond has only oxidation state -1, not -2. The remaining all oxygens have -2. Okay, now 2 hydrogens +2, 2 sulfurs 2x, and 8 among 8 oxygens, 6 oxygens oxidation state is -12. The remaining 2 oxygens which are in peroxide bond, -1 -2. So we need to careful here. Here among 8 oxygens, 6 oxygens oxidation state is -12, 6 into -2 -12, but 2 oxygens which are present in peroxide bond, peroxy bond, then -1 -2 equal to 0. So if you find x value, that is equal to +6. Next, so you can observe here the table. Some of the examples are also given here. Carbon dioxide.